Welcome to the Mass Gauntlet Design Day presentation. My name is Jael Alonso. I'm the team lead in this project and one of the electrical and computer engineers. Mohammed Alawami is the industrial engineer. Edselmo Biondi and Francisco Garcia are the mechanical engineers. Tom Lamantia is the biomedical engineer, and Brendan Pham is the second electrical and computer engineer in this team. So the main objective of our project is to design gloves that measure and display the amount of mass a user is holding while also providing additional time under tension calculations during exercise activities.
This is how we're having the approach to the problem. We researched patterns for a similar device and came up with a new innovation called the time under tension. We also researched possible sensors which we purchased from TechScan, and also we conducted three analyses which include thermal, cost, and power analysis.
So for the major system requirements, we planned on including 4 A201 TechScan pressure sensors. These are sensors we chose due to the comfort, flexibility, and the amount of pressure it can hold. We have also included designing our graphical user interface with a main menu, which will provide the data information needed in our project. This includes continuous weight measurements that a user is holding, as well as a time under tension calculator and a date and time application, which utilizes a real-time clock. A calibration menu will also be included, and this will allow the user to change specific settings to the way they see fit. Users will be able to calibrate weight readings if needed, and also be able to change the date settings, as well as reset any time under tension readings after completing their workout. The small TFT display shown on the right will also be utilized to display all this information in a compact and legible form. Lastly, heavyweight lifting gloves will be used for better grip performance, and 3D printed housing units will be created in order to ensure protection of electrical components.
My name is Tom Lamantia, and I'm going to be talking about the design concept. So for our Mass Gauntlet Smart Weight Glove, we created a design that includes several different parts, as well as 4 different force sensors that'll be used inside of the fingers of the gloves. And in addition to this, we will be having a microcontroller with a battery, separate unit, which then will be wired internally to the display screen and the button control, which will be used to control the modes as well as switch between different display options. On this slide, this is an internal look of both the battery and microcontroller unit as well as the display screen unit with the buttons. As you can see on the left, that's our battery underneath with the microcontroller on top of that. And that has its micro USB port, which can be used for charging. And then on the right, we have our display screen with our different button layout to control the device.
For the following 3 slides, I'll go over the system requirement verification. For interface requirement, power interface, we have tested and inspected the 3.7 volt lithium ion polymer battery in the Adafruit microcontroller, and it has passed the test successfully. And for 1.3 sensor interface, we haven't yet tested the 4 pressure sensors working together in the gloves, since we're still working on the progress of implementing the sensor into the gloves. However, we have tested each pressure sensor individually, connected the Arduino breadboard, where we got satisfying results. And for performance requirements, 4.1 sensor accuracy, we have failed to get 5% tolerance to the sensor accuracy of measuring the mass. Instead, we got 2.5% tolerance. And for 0.3 battery life, the battery life, we made sure it lasts minimum of 3 hours. And for the 4.5 unit converter, we have tested successfully, where the user had the option to set as kilograms or pound, whichever the user prefers. And for the performance requirement, we have tested the total time under tension for a user utilizing a cloud program with the microprocessor and measurements of the sensor, and has been successful. But for the last 2 features, the trip time under tension and the reset time under tension, we're still working on it and testing it in order to get the best result possible.
I will now be going over the demonstrations and testing procedures. For the sensor and code testing, we had to make sure that the weights were being placed exactly on the sensor due to how small the area of the sensor is. So maintaining the weight stable was done by using prop-ups and by taping the sensors down. The sensors were tested individually to make sure the sensors were functioning correctly using a prototyping kit that was purchased. We also tested the sensors connected in a parallel circuit, allowing us to see how the sensor readings combined with one another. Function testing was done within the Arduino IDE by using hard-coded data in order to ensure that the functions were calculating information adequately. This was then tested with the sensor readings as an input. In terms of the results, we were able to successfully create an organized graphical user interface for the user with functioning buttons, completed the functions for mass readings, including conversions from kilograms to pounds and vice versa, completed a total time under tension function, completed a date and time display with a real-time clock, designed and are currently implementing the functions for trip time under tension analysis and user settings, created 2 protective 3D printed housings for the mass gauntlet system, which was created for the TFT display and microprocessor, and we also began processing for a possible patent with our sponsor.
Deliverables to sponsor. Here are our deliverables. Our sponsor, Paul Efron, will be receiving the SmartWeight Glove prototype, glove software, technical data package, and operating manual. We're giving the sponsor our prototype and the documentation required to further iterate on the gloves. Here is our poster for design day. Feel free to pause the video to view it.
For surprises and lessons, we realized that everything will not go as planned. I personally experienced coding issues which took time to search for and fix accordingly, delaying plans for other portions of the project. The epidemic was also an issue since it made it difficult for team members to meet more frequently and work with one another. Miscommunication and part delays were frequent during this time as well, especially in regards with our suppliers. More often than not, our orders either arrived incomplete or did not come in at all, which resulted in our production lead having to call our supplier multiple times. While we encountered issues, we also learned more efficient strategies when communicating and working on our project. Constant updates were vital to ensure that no information or planning was lost or misunderstood. We also learned that there are pros and cons to every design choice, since one design choice can affect another aspect of the project. Keeping track of the most efficient choices is what promotes a successful project. And finally, hearing other opinions can bring forth better ideas in a product's improvement, something that I'm extremely proud of with my team.
Now for our acknowledgements and references. Our team cannot thank these 2 gentlemen enough. Shown here are our sponsor, Mr. Paul Efron, and our mentor, Mr. Bob Messenger. Throughout these past few semesters, Paul and Bob provided us with ample amounts of advice and oversight of our project, despite it being in the pandemic. We are grateful for Paul, who came up with the conception of the idea, and his willingness to take us on for this project. He has even made plans to include our team in the patenting process with SmartWeight gloves. We would also like to acknowledge TechScan for providing us with data sheets and other documentations needed for working with our sensors. With that being said, on behalf of Team 21052, thanks for watching.